You have now explored what a graph is, created your own graph implementation, and seen some of the common traversal, sorting, and classification algorithms of graph networks. It is important that you take some time to implement these algorithms yourself, if you haven't done so already. Using your graph implementation, you can now implement one of the traversal algorithms to traverse your graph and print its structure. After you do that, you should try and implement a topological sorting algorithm. Topological sorting will enable you to spatially order a graph. A real-world use of topological sorting is ordering, for documentation or production. If you have a production chain where each step is a node and directed edges are dependencies between these nodes, then a topological sort can return a valid order to perform each step. If you want to extend yourself further, you can implement algorithms that determine if a given graph contains a Eulerian circuit, or even find the minimum spanning tree of a graph. All of these algorithms are useful when dealing with big data stored in a graph network. Graph traversal is important in path finding, and finding the shortest path between two nodes. These types of algorithms are used in Google Maps, road networks, and even computer games. In a social network like Facebook, a traversal algorithm can be used to see if two people have any mutual friends. In a business context, an export business can be represented as a graph, with supply centers and delivery locations as nodes, where edges represent routes between these nodes. In this case, a traversal algorithm can be used to find a path between two locations. We have covered how we make and use graphs, but where does the data for our graph come from? Lots of data we want to use exists as files or on the cloud, and we can't store all of this data in our programs. It's simply too large, hence big data. What we want is for our program to retrieve this data, or more commonly a subset. Then it should perform our calculations, analysis, and manipulations before storing or sending the result back.